Hello everybody. In this lesson, we will study about solving a pair of linear equations algebraically by substitution method. We have already studied in another video of how to solve a pair of linear equations graphically. We graph them, and when the two lines intersect at a point, we learned that it has only one solution. And if the two lines are parallel to each other, we learned that it has no solution. And when two lines overlap each other, it has infinitely many solutions. And we determine this by graphing the two lines. But this is a tedious process. We can solve it in an easier way by substitution method. And we will see how to go about by the substitution method. Let's try this. Solve the following pair of linear equations by substitution method. Let's label the two equations as 1 and 2. The method is, the first step is choose any one of the equations of your choice. So let us go for the second equation, x plus 2y equal to 3. Then what you do is write one variable in terms of the other. In other words, isolate one variable on one side of the equal sign. So let's move the 2y on the other side. So we will have x equal to 3 minus 2y. Let's label this equation as 3. Now we will pick up the value of x, which is 3 minus 2y, and substitute it in equation 1 in place of x. So what do we get? 7 times x. Now x is 3 minus 2y. So we can substitute that over here. Minus 15y equal to 2. Now we can solve algebraically. We open the brackets. 7 times 3, 21, minus 7 times 2y, 14y, minus 15y equal to 2. 21 minus 29y equal to 2. Move the 21 on the other side of the equal sign, we get minus 29y equal to 2 minus 21. Minus 29y equal to, now we take the value of y, which is 19 over 29, and plug it in place of y in equation 3. So we get x equal to 3 minus 2 times 19 over 29. And we simplify that, we get x equal to 49 over 29. And we already know y is equal to 19 over 29. So this is the solution of this equation. Let's solve this pair of linear equations by the method of substitution. So we know the steps. Let's label the equations as 1 and 2. First step, choose any one equation of your choice. So let us go for the first equation, 2x plus 3y equal to 9. Then write one variable in terms of another. So let us write x in terms of y. So we move 3y on the other side. 2x is going to be equal to 9 minus 3y. Then x is going to be equal to 9 minus 3y over 2. Now we will take this value of x, which is 9 minus 3y over 2, and plug it into our equation 2 in place of x. So we get 4 times x. X is 9 minus 3y over 2 plus 6y equal to 18. And when we solve this, we get 18 minus 6y plus 6y equal to 18. If you observe over here, 18 is equal to 18. The left hand side is equal to the right hand side, and we don't have a y over here. It indicates that the equation will be true for any value of y. And because the equation will be true for any value of y, we will not have any specific value of x. So when we land up with such type of a situation, this pair of linear equations has infinitely many solutions. It has infinite solutions. In other words, the two lines are overlapping each other because they represent the same equation. Let's try this. The difference between two numbers is 26, and one number is 3 times the other. Find them. So let the two numbers be x and y, and let us consider x to be greater than y. Now the problem says the difference between two numbers is 26. So x minus y is equal to 26. And it also says one number is 3 times the other. So x is equal to 3y. So we can now label these equations as 1 and 2. If you observe, the second equation is already in terms of x is already written in terms of y. So we can directly replace the value of x in equation 1 by 3y. So if we replace x as 3y in the first equation, we have 3y minus y equal to 26. 2y is equal to 26. Y will be equal to 13. So now we know the value of y. We can take the value of y and plug it into equation 2 to get x. So x will be equal to 3 times y. Y is 13. So x is going to be equal to 39. So we have x 39, one number is 39 and the other number is 13. Let's try this. The larger of two supplementary angles exceeds the smaller by 18 degrees. Find them. First of all, what are supplementary angles? Two angles are said to be supplementary if the sum of those two angles is equal to 180 degrees. So let the two angles be x and y. And let us consider x to be greater than y. Now these two angles are supplementary. That means x plus y is equal to 180 degrees. And the question says that the larger of the two supplementary angles exceeds the smaller by 18 degrees. So x exceeds the smaller by 18 degrees is equal to y plus 18. Now we have a pair of linear equations. We can label them as 1 and 2. Observe the second equation. X is already written in terms of y. So we can take the x from equation 2 and replace it in equation 1. So we will have x is nothing but y plus 18. So y plus 18 plus y equal to 180 degrees. 2y plus 18 equal to 180. 2y equal to 180 minus 18. 2y is going to be equal to 162. And y is going to be equal to 162 over 2, which is equal to 81 degrees. Now we know the value of y. We can take the value of y and substitute it in equation 2. So equation 2, x will be equal to y, which is now 81, plus 18. So x is going to be equal to 99 degrees. So we know the value of x, we know the value of y. And when you add them, it's 180 degrees. So they both are supplementary. Let's try this. The coach of a cricket team buys 7 bats and 6 balls for 3,800 rupees. Later, she buys 3 bats and 5 balls for 1,750 rupees. Find the cost of each bat and each ball. So how do we go about? Let the cost of one bat be equal to x rupees. So let us take the cost of one bat equal to x rupees. And let the cost of one ball be equal to y rupees. So now 7 bats and 6 balls cost 3,800 rupees. So 7 bats will be 7x plus 6 balls will be 6y will be equal to 3,800 rupees. And the second part of the question says, later she buys 3 bats and 5 balls for 1,750. So 3 bats will be 3x plus 5 balls 5y will be equal to 1,750. Now this is a pair of linear equations and we can go about solving them. Let's label this as 1 and label this as 2. Now we can pick up any one of the equations. So let us pick up the second one and write y in terms of x. So we are picking up the second equation. So 5y will be equal to 1750 minus 3x. Y will be equal to 1750 minus 3x over 5. Let's label this equation as 3. Now we go to equation 1, plug the value of y of equation 3 and then find the value of x. So when we go to equation 1, we have 7x plus 6 times y. Now y is 1750 minus 3x over 5. We can plug that in over here. 1750 minus 3x over 5 equal to 3,800. Now we have a 5 in the denominator. So let us get rid of that 5 in the denominator. We don't want any fractions over here. So how can I get rid of that 5 in the denominator? I will multiply every term on both sides of the equation with 5 so that over here the 5 can be got rid of. And let's see what we'll end up with. So when we multiply every term with 5, what happens? This 5 will cancel this 5. 7 times 5, we get 35x plus 6 times 1750 minus 3x equal to 5 times 3,800, 19,000. Now we can open the brackets. 35x plus 6 times 1750 is 10500 minus 18x equal to 19,000. 35x minus 18x is 17x equal to 19,000. We bring the 10,500 on the other side, minus 10,500. So 17x is going to be equal to 8,500. X will be 8500 divided by 17, which is equal to 500. Now we know the value of x. We can take the value of x and plug it into our equation 3 to find the value of y. So our equation 3 is y equal to 1750 minus 3x over 5. And we know the value of x is 500. So we can plug the value of x. So y is equal to 1750 minus 3 times 500 over 5. And when we do the simplification, we land up with 250 over 5, which is 50. So y is equal to 50. So the and x is equal to 500. So the cost of one bat, we know that bat was represented by x. So the cost of one bat is 500 rupees, and the cost of one ball was represented by the variable y, which is 50 rupees. So this is how you solve a pair of linear equations by substitution. I hope you have understood this lesson. I appreciate your initiative in following through and giving a good try to improve yourself in math. Please share this video and subscribe for the channel. Thank you. Let's try this. A taxi charges in a city consist of a fixed charge together with a charge for the distance covered. For a distance of 10 kilometers, the charge paid is 105 rupees. And for a journey of 15 kilometers, the charge paid is 155 rupees. What are the fixed charges and the charges per kilometer? How much does a person have to pay for traveling a distance of 25 kilometers? So let us first begin with, let the fixed charge be x rupees and the charge per kilometer be y rupees. And the problem reads, for a distance of 10 kilometers, the charge paid is 105 rupees. We know that the charge per kilometer is y. So what will be the charge for 10 kilometers? It's going to be 10y. And this includes the fixed charge together. Together, it's going to be 105 rupees. The second part of the question says, for 15 kilometers, what will be the charge? It's going to be 15y. And we also have a fixed charge for that. And that together is 155 rupees. Now this forms a linear pair. So let's label them as equation 1 and equation 2. And then we can take the first equation, represent x in terms of y. So we will have from the first equation, from equation 1, x will be equal to 105 minus 10y. Now we can take this x and let's represent this as equation 3. We can take this and plug it into equation 2 in place of x. So we are plugging the value, the x, which is 105 minus 10y in equation 2. So x is 105 minus 10y plus 15y equal to 155. And when we simplify, we get 105 plus 5y equal to 155. 5y is going to be equal to 155 minus 105. 5y is going to be 50. Y is going to be 50 over 5, which is 10 rupees. So the charge per kilometer is 10 rupees. Now we can take the value of y and plug it into our equation 3. And our equation 3 was x equal to 105 minus 10y. So we can plug the value of y now, and y is 10. So x is 105 minus 100. So x is going to be 5 rupees. So the fixed charge is 5 rupees. The question also says that find out the charge for 25 kilometers. So we know that y represents charge per kilometer. So for 25 kilometers is going to be 25y, and it has a fixed charge. Now we know all the values. X is 5 plus 25 times y, charge per kilometer, is 10. Simplify it and we get 255 rupees. So the charge for 25 kilometers will be 255 rupees. Great. Let's try this. A fraction becomes 9 over 11 if 2 is added to both the numerator and the denominator. If 3 is added to both the numerator and the denominator, it becomes 5 over 6. Find the fraction. So let the fraction, the numerator be x and the denominator be y. The first part says if 2 is added to both the numerator and the denominator. So I add 2 to both the numerator and the denominator. The fraction becomes 9 over 11. Can we write it in a linear form instead of having a fraction? So let's cross multiply them. So we get 11 times x plus 2 is equal to 9 times y plus 2. Open the brackets. 11x plus 22 will be equal to 9 times y, 9y, plus 9 times 2 is 18. Move the x and the y on one side. So 11x minus 9y is going to be equal to 18 minus 22. So 11x minus 9y equal to minus 4. Let us label this as equation 1. That is the first part of an equation. The second part of the equation says if 3 is added to both the numerator and the denominator, it becomes 5 over 6. So if 3 is added to both the numerator and the denominator, it becomes 5 over 6. So now the same thing we can do over here, cross multiply. So it becomes 6 times x plus 3 equal to 5 times y plus 3. Open the brackets. 6x plus 18 equal to 5y plus 15. Move the x and the y on one side. 6x minus 5y equal to 15 minus 18. 6x minus 5y is going to be equal to negative 3. So let's label this equation as 2. So now we have the two equations. 11x minus 9y equal to negative 4 and 6x minus 5y equal to negative 3. These are the two equations we landed up with. From here, I leave it upon you to solve by substitution for x and y. And you already know the method, and I'm sure and I'm confident that you will be able to do it. So when you solve these, and if you're right in solving, which I am sure you will, the fraction will be equal to 7 over 9. See whether you get this. Let's try this. 5 years hence, meaning 5 years from now, from the present age, the age of Jacob will be 3 times that of his son. 5 years ago, Jacob's age was 7 times that of his son. What are their present ages? So let's begin with, let the present age of Jacob be X years and the present age of his son be Y years. The question says 5 years hence, meaning 5 years from now, the age of Jacob will be X plus 5 and the age of his son will be Y plus 5. It says that Jacob was 3 times that of his son. So Jacob's age was 3 times that of his son. So this forms an equation. We can open the brackets. So X plus 5 is going to be equal to 3y plus 15. Move the x and the y on one side, so it's going to be x minus 3y equal to 15 minus 5. X minus 3y is going to be equal to 10. This can be one part of the equation, one equation. And the second part of the question says 5 years ago. So if the present age of Jacob is x, 5 years ago the age of Jacob will be x minus 5 and his son's age will be y minus 5. 5 years ago Jacob's age was 7 times that of his son. So the Jacob's age was 7 times that of his son. Now we have represented that problem in the form of an equation and we can simplify it now. X minus 5 equal to 7y minus 35. Bring the x and the y on one side. X minus 7y minus 35 plus 5. So x minus 7y equal to minus 30. This is the second part of the equation. So now we have a pair of linear equations, x minus 3y equal to 10 and x minus 7y equal to minus 30. I leave it upon you to solve the values for x and y by substitution method, and then I am sure you will get the right answer as x equal to 40 and y will be equal to 10. In other words, Jacob's age was 40 years and his son's age will be 10 years. So I am confident that you will get these answers. Good luck. Keep trying. Keep watching. Keep sharing. Thank you.